Welcome back to Decoded by Mo. In episode 1, we zoomed way out, talking about AI, nations, sovereignty, and why the future of power might depend as much on chips and compute as on oil or armies. But today, we're going to pause, take a little detour, and slow down. Call this episode 1.5. Why? Because before we go deeper, I want to make sure we're all speaking the same language, that we have the same toolkit to decode AI. Not jargon, not hype, not insider acronyms, just the real stuff. How AI works, who the big players are, what GPUs have to do with it, and why the terms like LLMs, SLMs, parameters, tokens, and even hallucinations keep on coming up. By the end of this episode, you'll not only get it, you'll be able to explain it to your colleagues, your boss, or even the cousin at family dinner who insists AI is just Skynet waiting to happen. So let's rewind, decode, and put AI into plain English. Let's start with the basics. When we say artificial intelligence, what do we actually mean? At its core, AI is simply about teaching computers to do things we once thought that only humans can do. And it usually shows up in three big ways. First, machine learning. Instead of writing rules for a computer, we feed it examples and let it learn the patterns. Show it 100,000 emails labeled spam or not spam, and it figures out the difference in its own. Then there's deep learning, a special kind of machine learning that uses structure inspired by the human brain, called neural networks, to uncover deeper, more complex patterns. And finally, generative AI, the celebrity of the moment. This isn't just recognizing things, it's creating text, art, music, code, or even videos. But AI didn't just appear out of nowhere. Let's rewind the tape for a quick history flash. Back in 1956, at Dartmouth College, a small group of researchers coined a new term, artificial intelligence. They were wildly ambitious. They thought machines could rival human intelligence in just a few years. Spoiler alert, they were a little optimistic. By 1966, we saw the birth of ELIZA, the first chatbot ever. It pretended to be a therapist by repeating your words back to you as questions. Whereas you say, I feel stressed, ELIZA would answer, why do you feel stressed? That was it. And yet, people poured their hearts to ELIZA, convinced it understood them. In the 1980s, neural networks became the hype train. Researchers thought they cracked the code, but the computers were too weak, the data too limited. Funding dried up, people walked away. What followed was the AI winter, like the dot-com crash, but much colder. Then in 2012, everything changed. A system called AlexNet crushed the competition in an image recognition contest. Suddenly, deep learning wasn't theory anymore. It was the best tool we'd ever had for spotting patterns in a massive amount of data. Fast forward to 2018. OpenAI released GPT-1, only with 117 million parameters, tiny by today's standards, but revolutionary. It didn't just analyze text, it generated it. And then came 2023, GPT-4, rumored at over 1 trillion parameters, trained on trillions of words. AI was no longer an experiment. It was in your phone, your office suite, your art tools, and even on your fridge. And just like that, what started as an ambitious summer project at Dartmouth became the biggest technology wave since the internet. And with the explosion came something else, acronyms. Suddenly, everyone was throwing around mysterious terms, LLMs, SLMs, GPUs, AGI, and many, many more. If you've ever sat in a meeting and just nodded along the way secretly thinking, wait, what did they just say? Don't worry, you're not alone. Let's break them down. Start with the one you've definitely heard, LLMs, or large language models. Those are the big guys. Trained on enormous data sets, they're designed to predict the next word in a sentence, which sounds simple, but it's core of why they can write essays, solve code, or even tell you a bedtime story. Basically, autocomplete on rocket fuel. Think of it this way. If a human writer is a chef with a cookbook, an LLM is a chef who's read every recipe in existence and can improvise new ones instantly. Sometimes brilliant, sometimes, well, pineapple on pasta. Take GPT-3 from 2020, 170 billion parameters, then GPT-4 in 2023 with over a trillion parameters, with a training bill north of $100 million. Now compare that to SLMs, small language models. These are lighter cousins. They don't know everything, but they can run on your laptop or even your phone. If LLMs are the big libraries, SLMs are the pocket guides. Faster, cheaper, and surprisingly handy. But there's another distinction most people miss: the difference between a model and a platform. Here's the simplest way to think about it. The model is the brain. The platform is the body. The model is pure intelligence, just math and weights. You can't really talk to a raw model. It's like having Einstein's brain sitting in a jar. Brilliant, but not very useful on its own. The platform is what makes the brain accessible. The interface, the app, the integration. It's the reason you could actually use the model. GPT-4 is the model. ChatGPT is the platform. And when Microsoft adds its own Word and Outlook and calls it Copilot, that's another platform powered by the same brain. So next time someone says ChatGPT, remember, are they talking about the model or the platform? Most people mix them up. The next obvious question is, who's actually building these brains and who's packaging them into platforms? Right now, it's like Champions League of AI. Different teams, different styles. OpenAI with ChatGPT is the one that made AI mainstream. Anthropic with Claude, the polite, cautious cousin focused on safety. Google with Gemini, deeply tied into Google's ecosystem search, Docs, and Gmail. Elon Musk's Grok, the snary one, built into Twitter, always with attitude. DeepSeek from China is the fast, cheap, optimized for efficiency. And Mistral from France or Europe, the open source star, small but mighty. As well as Falcon from Abu Dhabi, which is the Middle East flagship AI model. And Meta's Llama, hugely influential across the open source world. Here's the rule of thumb. Closed source models are like Coca-Cola, secret recipes. Open source models are like grandma's couscous recipe, shared with the world for anyone to remix and improve. But what actually makes those models tick? Let's look under the hood. Inside every model are parameters. Think of them as the tiny switches in the brain of AI. During training, each switch adjusts, capturing patterns in data. The more switches, the more complex the patterns. GPT-3 had 175 billion. GPT-4, as I said before, rumored to have over a trillion. That's like going from a city of light bulbs to a galaxy of stars. Then there are tokens. AI doesn't read words like we do. It chops everything into chunks called tokens. One token is about 3/4 of a word. So the phrase artificial intelligence is 3 tokens. Why does it matter? Because tokens are the unit of memory. GPT-4 can juggle 128,000 tokens in one go. To put that in human terms, it can read War and Peace cover to cover and still remember the first chapter. And then there are foundation models. These are the raw, general purpose brains, trained on everything from books to Wikipedia to code. They can then be fine-tuned for specific tasks like law, medicine, or finance. The foundation model is the block, fine-tuning shapes into a doctor, a lawyer, or even a poet. Now, knowing what's inside is one thing, but how do those models actually learn? It happens in two stages: training and interference. Training is like sending AI to university. It's long, expensive, and GPU hungry. That's why training GPT costs over $100 million. Once trained, the knowledge is baked in. Interference is using that education. Every time you ask ChatGPT a question and it replies, that's interference. Faster, cheaper, practical. Then you have fine tuning, giving AI a speciality. A bank might fine tune GPT for compliance tasks. A hospital might fine tune it for medical notes. But here's the twist: none of this, not training, not interference, not fine tuning, happens without hardware, the chips. And this is where GPUs come in. Now, most people have heard the acronym GPU, but if we're honest, what the hell is a GPU anyway? GPU stands for Graphics Processing Unit. Originally built for video games, they handled the heavy lifting of rendering 3D graphics, explosions, shadows, virtual worlds. The magic of GPUs is that they can do lots of calculations at the same time. A CPU, the main brain of your computer, is like brilliant office worker who solves problems one after another. A GPU is like having 10,000 less brilliant interns working in parallel. Perfect for graphics, and as it turns out, perfect for AI. Because training AI models is basically huge math marathons, multiplying and adding billions of numbers over and over. CPUs would choke. That's why GPUs became the Formula One engines of AI, built for gaming, repurposed for intelligence. And they're expensive. NVIDIA's H100 chips go for $25,000 to $40,000 each. Training GPT-4 took somewhere between 20,000 and 30,000 of them. That's hundreds of millions of dollars in hardware before you even pay the electricity bill. And they're scarce. Everyone, big tech startups, hedge funds, governments, is hoarding them. NVIDIA dominates supply, which is why their revenue tripled in a year. So yes, CPUs are like family cars, GPUs are Formula One race cars, and right now, there aren't enough race cars to go around. A lot of people might have not heard this phrase, multimodal AI. It sounds fancy, but let's break it down. Multimodal simply means many modes. In AI's case, that means many types of information: text, images, audio, even video. Traditional models usually focus on one thing, just text or just images. But multimodal AI tries to replicate what our brains do, integrate all our senses seamlessly into one understanding. Think of it like this: a text only AI is like talking to a friend on the phone. You get the words, but you miss the tone, the facial expressions, the context. A multimodal AI, that's like sitting face to face, and it's already happening. GPT 4.0 can look at an image, listen to your voice, and reply instantly. Google's Gemini can handle text, images, and audio together. And the next step is full video and action. AI that doesn't just answer, but interacts with the world the way we do. Then there's hallucination. In AI, this isn't psychedelics. It's when the model makes things up, like asking for direction and being sent into a lake. A single NVIDIA H100 costs more than a car. Nations treat them like oil reserves. We've gone from who controls the oil to who controls the GPUs. Here's the bottom line. You don't need to solder GPUs or memorize token math, but if you want to spot hype from reality, understand the geopolitics, or see opportunities in business, you need this foundation. Because AI isn't magic, it's math, data, and compute, shaped by whoever controls the models, the chips, and the platforms. And whether you're a policymaker, a founder, or just curious, knowing how it works means you're playing the game, not just watching from the stands. So that's AI 101 decoded. From LLMs to SLMs, platforms to GPUs, and all the quirky, geeky, sometimes hilarious details in between. That was Decoded by Mo. Thanks for listening. Stay curious, and peace be with you.